Hi everybody, this video is the first video for section 16 using the graphing calculator or other technology to solve for all the different quadratic features. But we're also going to use this as a review for section 15, so this way we can put everything together with what we've learned and do a complete quadratic problem. So this is going to serve both of those purposes. A little bit of review for all the formulas that we learned in chapter 15, all the features, and then we're going to do chapter 16 or section 16, which is using the technology. So given the function f of x equals 15x squared plus 2x minus 3, we're going to answer the following questions. Part A, will the parabola open up or down, and how can you tell by looking at the formula? Well, the formula is a quadratic. It's of the form ax squared plus bx plus c. And so we know that the way to tell if a parabola opens up or down is if the a value is either positive or negative. So in this case, a is positive 15, which tells me that it's going to open up. So I can say the parabola opens up because the a value is positive 15. And that's how we can tell. Now, what does open up mean? It means we're going to have a U-shaped graph as opposed to an upside down U, because a parabola is a U-shaped graph, either open up or open down. All right, part B. What is the y-intercept of the graph, and how can you tell by looking at the formula? The formula, 15x squared plus 2x minus 3, let's mark down our B and our C. B would be 2, and C would be negative 3. And we learned that the C value is always our y-intercept, because if you were to plug 0 in for x, these two terms would drop out and you would be left with the C term every time. So since the y-intercept occurs when x equals 0, it's always going to be that constant term. So the y-intercept is the point 0, negative 3 for this particular quadratic, and we can tell because negative 3 is the C value. And that's review from the previous video. Now let's start to throw in a little bit of technology. It says graph the function from x equals negative 3 to x equals 3, and make sure you set a window that allows you to see the complete shape. So we're going to do this two different ways. We're going to do this using our graphing calculator and Desmos, because I know not everybody has access to a graphing calculator from home. So here's the graphing calculator. We're going to go into y equals, and you're going to type in the function. So that's what I have here. And now we need to set an appropriate window. So we're going to go to window, and we're going to do what they told us, x min of negative 3 and an x max of 3. Because that is not a very wide range of numbers, we're just going to count by 1. That's what x scale means. So it means we're counting by ones. So we don't have to touch, or we know, they told us, pretty much the first 3 values. We just need to worry about a y min, a y max, and a y scale. So let's go back up here and see if there's anything that looks particularly large. So none of these numbers look very large. I know that I have to see the point 0, negative 3 at the very least, because that's the y-intercept. So I think that maybe starting from negative 10 to 10 is not really a bad option. Okay, I can keep that as an option here. So now I'm going to hit graph. This is what the graph looks like with that window. Now I could go back and I could get rid of some of this white space down here by increasing the y min, but I don't really have to. I mean, I see all the important features. I see the vertex, I see the y-intercepts, I see the x-intercepts. So I can leave this as a pretty decent window. So I'm gonna write this down. The window that I used was -3 for the x min, 3 for the x max, and 1. And for the y's, I left it from -10 to 10, counting by ones. So that's the window that we chose to use here. If you're going to use Desmos, you're going to go to desmos.com. And over here, you're going to type in the function, so 15x squared plus 2x minus 3. And this is the type of picture that you're going to get. Right now, this does not have the -3 to 3 on the x-axis that they wanted me to have. So I can go up to this little wrench up here, and I can set values for my x-axis and values for my y-axis. So I'm going to change my x-axis to go from -3 So we're changing this to -3, and we're going to change the max to 3. So now you can see that changed my y or my x axis. And the y axis doesn't really matter. I mean, I'm still seeing the whole graph. So if you want to play around with that, you can. But that would be how you adjust the window on Desmos. Okay. Next question. Find the vertex algebraically and then graphically. So the algebraically part is to review the last video. To find the vertex algebraically, first I need to find the axis of symmetry. So the formula is x equals -b/2a. And I'm going to have to plug in the values of b and a. So back up to the top, if I look at the original function, my b is 2. So it's going to be -2 over 2 times 15. So this is -2 over 30. You have to evaluate the numerator and denominator separately. And this simplifies to -1/15. Now, that gives you an ugly decimal. If you were to put that in your calculator, that gives you -0.066666 repeating. Okay, so we can put that here, but it's approximate, -0.0667, okay, if we wanted to round. We don't want to put any rounded number in as an input, because if you round your input, that means you don't have an accurate output anymore. So we want to use the exact input when we're evaluating. So to find the y value, I have to evaluate the function at -1/15. So everywhere I see x in the original function, I'm going to type in -1/15. And you can do this directly in your calculator the way that it looks. So let's do that together on our graphing calculator. I'm going to type in 15, open parentheses, -1 divided by 15, close parentheses, squared, plus 2, open parentheses, -1 divided by 15, and then -3. And I'm going to hit enter. Now that's going to give me an ugly output. I can write that here just so I can document what I'm getting. This is approximately negative 3.0667, okay, and I can round that off. But if I want to get an exact output, I can make my calculator do that by going to Math, so the button Math, and then choosing number 1, choosing frac, and hitting enter. And now I can see that negative 46 over 15 is my exact answer. And so now I actually have 2 possibilities for how I could write this ordered pair. The exact ordered pair is negative 1/15, comma 46/15. The approximate ordered pair is negative 0.0667, comma negative 3.0667. And they're both going to be helpful in their own way. Now I want to verify this graphically. So I'm going to go back to the graphing calculator and back to the graph of the function. I want to find the vertex. Well, the vertex is the turning point. In this case, it's the minimum because it's the lowest point of the graph since it's face up. I need to find that minimum. So I'm going to go to our trusty menu, second trace. And I'm not going to choose number 5. That's been kind of our go-to. Now I want to find a minimum. So that's going to be choice number 3. So I'm going to hit number 3. And then I have to follow the prompts. It says left bound. I'm going to go anywhere to the left. So anywhere on this side of the valley. And I'm going to hit enter. And then it asks me right bound. I have to pass through and go anywhere to the right of the valley. And then it says make a guess. So I go somewhere close to the valley and I hit enter. You are not done until you see the word minimum or maximum, if it were a maximum, on the bottom of the screen. So now you can see that I get negative 0.0666 and I get y equals negative 3.0666. So it does correspond to my algebraic answer. So that's how you would use your calculator to find the minimum. Now, if you use Desmos to find the minimum, you actually don't have to do anything because Desmos, with its features, all you have to do is touch the graph and all the important features are already there. So I don't have to do anything special. I touch the graph and I touch the minimum point and I see that I get negative 0.067 and negative 3.067. So again, it verifies. And Desmos is a little bit easier because it'll just automatically finds your special points of the parabola. Okay, now it says find the x-intercepts graphically. We're doing graphically first because we don't know how to do this algebraically yet. We're going to learn algebraically in the next section. So first we're going to do this graphically. When do x-intercepts occur? Let's write this down. X-intercepts occur when y equals 0. If I have a y value, I have to go to y equals to tell my calculator that. So in y2, I'm going to type 0 because that's what I'm interested in. And then I'm going to go back to my graph. Now you can see mine drew a red line right on the x-axis because I'm saying that I want y to be 0. And I want to find these 2 points where they intersect. So I'm going to go to second trace, the calculate menu. Now I want to go back to our trusty number 5. And I'm going to follow the prompts. Get as close as I can to that first point of intersection. Keep hitting enter until I see the word intersection. And now I know that one of my x-intercepts is negative 0.519 if I round, comma 0. But I don't have just one. I have 2 x-intercepts. So I have to go through the whole process again. Second trace, number 5, go over to the other intersection, keep hitting enter until you see the word intersection, and I get 0.385, comma 0. And those would be my 2 x-intercepts. If you're using Desmos, again, the features are already there for you. Just touch the graph, and you can see that it tells me what they are. So I see that negative 0.519, and I see 0.385. So exactly what we got using the graphing calculator. And I don't really have to do anything for Desmos. It just automatically will pop up. All right, so far so good. Using technology to find all the important features. Now we want to find f of 1 symbolically and graphically. So let's do symbolically first. Ask yourself, is this an input or an output? Since it's in place of x, it's an input. So if I want to find f of negative 1, that means everywhere there's an x, I'm going to plug in negative 1. And I can put this on the calculator. And I wind up with 10. So f of negative 1 equals 10. Now, if I want to do this graphically, on the graphing calculator, it's actually easier, okay, surprisingly. All I have to do is hit trace, just trace, not second trace, just trace, and type in the input that I'm interested in. So type in negative 1, hit enter, and you wind up with an output of 10. Okay, so it's easy to type in an input just using the trace feature. If you're using Desmos, okay, you're going to type in the x value that you want. So you're going to type in x equals negative 1. And the good thing, I guess, about Desmos is that it can draw vertical lines. Your graphing calculator cannot, because a vertical line is not a function. But now you can see that if you hit the graph, okay, just like before, Desmos will just tell you what that intersection is. And so you can see that when x is negative 1, y equals 10. So that's how you would use either technology for that. Solve f of x equals 50 graphically. Okay, again, it's graphically because we don't know how to do this algebraically yet. So let's go to our graphing calculator first. I've got the function in y1. That 50 is now an output, which means it's a y value. It's just like saying y equals 50. And so I'm going to go back into y2, and I'm going to change y2 to 50. However, if I want to make sure that I see this, I need to readjust my window because my window is not showing me 50. So I have to go back into window, and I have to adjust my x max to at least see 50. So maybe I'll go up to 60, and I'll count by tens. And let's see what that graph looks like. Here comes the parabola. And there comes the line of y equals 50. Now I want to find these two intersection points. So that's the same process as before. Second trace, number 5. Follow the prompts. Keep hitting enter. I get x equals negative 1.9476. So x is approximately negative 1.9476. And then I have to do it again because remember, there are two intersections. So second trace, number 5, go through the whole thing again, except go to the other one. So bring your cursor to the other side, keep hitting enter. Says intersection, so another time when x is approximately 1.8142. And as long as you round correctly, I don't really mind what you round to, but if the directions tell you to round to a certain number of decimals, make sure you follow the directions. Very often it'll say 4 decimal places, which is why I've been doing 4 decimal places here, okay? So just make sure you round correctly. If you're going to use Desmos, we can delete what we put in the second spot here, and we can say that we want when y equals, and you do have to put y equals when you're doing a constant, I realized. So we're going to put y equals 50, and we're going to hit enter. Okay, now here's another nice thing, or maybe not nice thing, depending on how you think about it, for Desmos. It doesn't automatically adjust the window. However, it is movable, so you don't have to necessarily adjust the window. You can just move the screen with your finger and then find those 2 points. So again, just tap and it'll tell you those 2 points. So negative 1.948 and then 1.814. And Desmos will go to 3 decimal places, it looks like. Okay. If you did want to adjust your window in Desmos, again, it's the wrench. And then I could change my X or Y axis to go up to what I want. So if I wanted to change my Y axis to go from negative 10, just like on my graphing calculator, to 60, okay, then I can do that. And I can make sure that I see the whole thing. So you can play around with this as much as you want. Okay, just to get used to Desmos if you don't have your graphing calculator. And last but not least, we have when will the graph reach a height of 14? Height is your key word here. Height is which direction? Is it the X direction or is it the Y direction? Height is vertical, so it's the Y direction. This is just like saying when Y is 14. So there's really not much difference between G and H. They're giving me an output in both cases. So I'm going to go back into my graphing calculator, into Y equals, and instead of 50, I'm going to put 14. I can readjust my window if I want, because I don't have to go as high anymore. So maybe I'll bring it down to 20 for my Y max. It's going to draw in the parabola. It's going to draw in Y equals 14. And then I go through the same process and I find these 2 intersection points. So I'll leave that one for you to do. Okay, I just wanted to make sure that you understood what the word height meant if they told you to go for a specific height. So I hope this video made sense. If you have any questions, please let me know. There are benefits to both, either the graphing calculator or Desmos. So use whatever technology you have, or if you prefer Desmos over the graphing calculator, you're welcome to use Desmos. All right? I hope you have a wonderful day.